the fundus. This is where gas accumulates in the stomach for like the belching that my daughter's really good at. The body, and then the pylorus right here. That's the bottom. This is called the pyloric sphincter that moves it's the movement of food from the stomach into the small intestine. It controls that. This is the lining of the stomach. So this is that mucosal layer, and it has these really deep grooves within it. And at the bottom, these are called gastric glands, and then these holes actually in it are called gastric pits. Within these gastric glands, we're going to have the secretion from these cells, and we're going to talk about what these cells release, and you're going to have to know specifically which cell releases. So we got exocrines, then we have endocrine glands in there. The exocrine glands secrete, the mucus neck cells, this one's easy, produce mucus. The parietal cells in those gastric glands produce intrinsic factor and HCl, hydrochloric acid. And then the chief cells produce pepsinogen, which is going to be converted into pepsin, digest proteins, and then gastric lipase. Lipase helps to digest fats. And then also in there, you have the endocrine cells, the G cells, that secrete that hormone gastrin that helps spur along the production of the gastric juice. Together, the combination of those three cells, the mucus cells, the parietal cells, and the chief cells, all three of their products produce gastric juice. This is also kind of cool yet gross. 2 to 3 liters per day produced in the stomach. Now you might ask, hydrochloric acid, that's kind of a strong acid. Wouldn't that eat your own stomach? Wouldn't that be kind of bad? Well, yes. But it's protected. Your stomach is lined or produces enough mucus every day to make it very alkaline in the surface, or opposite of acidic, basic. So why is it acidic in the stomach? Well, it's going to kill microbes that are brought in there. It's going to partially denature proteins because of its acidity. And then it needs to be acidic in there to convert the pepsinogen released by the chief cells, right? Chief cells into pepsin. Just make sure on that one. Yes, okay, chief cells. And then what the lipase splits triglycerides. That's what it does. Why do we need intrinsic factor? You've probably never heard that word before. We talked about a little bit in the immune system, but it's needed to absorb vitamin B12 later on in the digestive system. And vitamin B12 is very important for red blood cell production. If somehow that balance between the amount of HCl produced, pepsin produced, and mucosal defenses in the stomach is off somehow, too much acid, not enough mucus, for example, the stomach lining can actually start to erode. My husband is building something, which can cause a little erosion, which would be painful and or not or prevent the stomach from doing its job. This is a view from the inside of the stomach. Well, this is bleeding and swelling due to that erosion. What can cause that? Consumption of too much acid, or drugs like too much ibuprofen. So that's why you got to follow the guidelines on how much to take, and actually too much aspirin as well can do that. Every 15 to 25 seconds, we have rhythmic waves that come through the stomach. They're going to mix the contents of the food together the chyme together in the stomach, and cause it to come in contact with the gastric juice, and eventually produce this chyme, this liquidy solution. Now, it's not a solid, it's more of a liquid. This is just showing um, homeostatic loop of how pH and the distension of the stomach, the increased amount of pH in the stomach from the gastric juice, essentially it works. You can take a look at that on your own. All right, so the stomach, major purposes. So we secrete the gastric juice. We're gonna further digest carbohydrates and lipids in the stomach. Not a whole lot is absorbed in the stomach as far as nutrients. Alcohol is absorbed in the stomach. That's why you see the effects of it rather quickly than other things. But the purpose isn't to absorb nutrients overall. It's just to help digest carbohydrates and lipids, and then also proteins. Starts in the stomach. Protein specifically. After about 2 to 4 hours after you eat a meal, everything is moved from the stomach into the small intestine. And the first part is called the duodenum. Different foods that have different amounts of carbohydrates, proteins, lipids stay in the stomach different timelines. Carbohydrates move through more quickly. They spend the least time. So you're hungry quicker if you just eat carbohydrates. For cereal, for example, cereal milk for breakfast, you're going to be hungry faster compared to if you eat a high protein breakfast. So eggs, for example, they remain somewhat longer in the stomach. And then the last to leave the stomach are fat-laden meals. So eggs with a lot of butter, and then some hash browns with butter, and then you eat maybe you eat butter. So just it takes longer for your body to digest it, to move it through the stomach. The stomach does then start moving food into the small intestine through the sphincter. And once it's in there, in that duodenum, then the intestinal phase begins. And we'll talk more about what happens after food gets into the small intestine.